with how blood is moving, right? So objective 3, to identify all phases of the cardiac cycle, understand origin of pressure, and describe the relationship between pressure and volume. So this is really that coordination between how the electrical activity is moving through the heart, how the atria are depolarizing, moving that blood down into the ventricles, how the ventricles are squeezing and relaxing and filling, and then eventually squeezing that blood out into the arteries. Now, when we talk about the phases of the cardiac cycle, you want to bear in mind that we're really focusing on what's happening in the ventricles, okay? The ventricles are actively contracting and relaxing, and that's what's moving the blood, right? The change in the pressure, mainly in the ventricle, is what's controlling the cardiac cycle. So we'll start out with the phases of the cardiac cycle. We'll then talk about the different pressures in the atria and the ventricle. We'll get to the pressure in the aorta, which is really important. This is where we get our blood pressure, systolic and diastolic. Then we'll talk about how the volume in the ventricles change. And then finally, we'll look at how all of this correlates to what's happening with the heart sounds. And by the way, the heart sounds and the ECG or the EKG are probably the two most useful pieces of information that tell clinicians about the heart, as well as blood pressure. So blood pressure, the ECG, and the heart sounds, without, the doctor listens with a stethoscope, are probably the most important pieces of information that we can take from a patient to give us information about how the heart's doing, how well it's functioning, the size of the chambers, how the valves are moving and working, and so on. So we start off with the cardiac cycle, really the events that are associated with the flow of blood through the heart within a single heartbeat. There are two main periods of the cardiac cycle. There's systole, which is ventricular contraction, and diastole, which is ventricular relaxation. So I mentioned this just now, right? We're really only focused on what's happening with the ventricles when we talk about these two main periods of the cardiac cycle, ventricular contraction and ventricular filling or ventricular relaxation. Now, we talked about this before. The opening and closing of valves is really a passive event. This happens due to the gradient, the pressure gradients that are created across that valve. So in order for the AV valves to open, the pressure that's within the atria must exceed or be higher than the pressure that's down in that ventricle. And so naturally, it's going to create a pressure gradient that just kind of forces that AV valve open. And to remind ourselves here, the AV valves are inclusive of the bicuspid valve and the tricuspid valve. The semilunar valves, which are the aortic and pulmonary valves, will likewise only open when the pressure that's in the ventricle is higher than or exceeds the pressure that's in that artery, whether it's the aorta on the left side of the heart or it's the pulmonary artery on the right side of the heart. So the opening and closing of valves is a completely passive process, and it relies upon the pressure gradients that are created between the respective chambers and arteries, or between the respective chambers. So let's start out by looking at the first phase of the cardiac cycle. This is called ventricular filling. And so this is basically starting at the middle of diastole. So the heart is in the middle of its filling phase, the ventricles, right, being filled from the blood that's moving down from the atria. And so we've got all of that venous return. Remember, venous return is blood that's coming back into the right side of the heart, blood that's coming in through the inferior vena cava from the lower extremities, the abdominals, and blood that's coming in from the superior vena cava, which is the head and the upper extremities and the neck region and so on. And so all of that blood fills back into the right atrium. And the middle of diastole is the middle of the period where that blood is now spilling down into the ventricle. Here, the AV valves are open as we would expect because the ventricle is filling and blood is moving from atria to ventricle. Likewise, the pulmonary valves and aortic valves are closed because we cannot fill the ventricle and still empty the ventricle at the same time. And so we've got this passive opening of the AV valve because the pressure from all of that venous return is now higher in the atria than it is down in the ventricles. And so those valves can passively open up. So this is the first phase, which is ventricular filling, or phase 1. The second phase is called isovolumetric ventricular contraction. This is where we actually start systole. So phase 1 ends diastole. It was the middle of diastole to the end of diastole. And phase 2 is the start of systole. Remember, we said systole is ventricular contraction or ventricular emptying, right? Now, during isovolumetric ventricular contraction, the ventricle has begun contracting, right? It's not emptying just yet. What we see is that the pressure in the ventricle is rising as the ventricle itself starts contracting. Neither of the valves are open. This is why this phase is called isovolumetric. Blood is neither entering or leaving this chamber, and so the volume remains the same for this very brief second phase. And so what we see is that the pressure in the chamber is rising. And remember, the semilunar valves are not going to open just yet because we need the pressure to be high enough in the ventricle to be higher than the pressure in that artery in order to open up the semilunar valves. And then the AV valves are not open yet because the pressure in the ventricle is higher than the pressure in the artery, in the atria. And we know that if the pressure in the ventricle is higher than the pressure in the atria, then the AV valves will not be open. So at this time, neither of the valves are open. What's happening is the pressure is rising as the ventricle is contracting, but the volume is remaining the same. And it's a very brief period when compared to phase 1. Now we get into phase 3. So phase 3 is the start of ventricular ejection or ventricular emptying. This is another part of systole. So systole is inclusive of phase 2 and the longer phase 3. This is where the ventricle can now empty because the pressure in the ventricle is now higher. It now exceeds the pressure in that artery. And so that semilunar valve, which could be the aortic or the pulmonary, depending on what side we're on, will now completely passively open. Right? So the ventricular pressure is less than aortic pressure. As we empty that blood, so remember, as the blood leaves the chamber, the pressure is now going with it. And so the ventricular pressure is now going to slowly drop beneath the aortic pressure. And that's what's going to close that valve once again. Right? So let me explain this here one more time. So we start ventricular ejection. When that pressure in the ventricle is now higher than the pressure in the artery, that semilunar valve can now fly open passively. And as the blood is leaving that ventricle, and I'm gonna kind of point this out on my GIF over here. So as the blood is now leaving this ventricle, making its way into the artery, the pressure is also dropping because as blood moves out of the chamber, the pressure now starts to drop. So when that blood leaves, the ventricular pressure now drops below the pressure in the artery, and so the semilunar valves will close once again, okay? The fourth and final phase is isovolumetric ventricular relaxation. This is the start of diastole. Remember we said diastole is the end, is phase 4 and phase 1. Systole is phase 2 and phase 3. So phase 4 is really the onset of a new diastolic phase. This is where the chamber starts to relax. So the ventricles begin relaxing. Their pressure can now decrease. And so the AV and semilunar valves are completely closed here once again. And I'll explain why both valves are closed. Remember, valves only open when the pressure in the preceding chamber is higher than the pressure in the next or the subsequent chamber. And so both valves are closed here because the pressure is falling. It's not low enough yet to open the AV valves, but it's not high enough to open the semilunar valves. And so as this chamber relaxes, the pressure also falls until we get to a state where the pressure in the ventricle is once again lower than the pressure in the atrium, and that will allow the AV valves to open up once again. And we'll start an entirely new cycle because that will be phase 1. Okay. But important to remember here, during isovolumetric ventricular relaxation, no blood is leaving or entering the ventricle because both sets of valves are closed. Both the AV valves and the semilunar valves are closed as that ventricular pressure drops as the ventricle relaxes. And so here's a really nice kind of cumulative representation of all of the phases and where they fit in terms of systole versus diastole. Remember, we start off with phase 1, which is the middle to the end of diastole. Then we move into phase 2, that isovolumetric phase, which starts systole here. The ventricular ejection phase, where the ventricles are emptying or squeezing that blood out, is the end of systole. And then we start another diastolic event with the phase 4, which is isovolumetric ventricular relaxation once again. And that can culminate in a brand new phase 1, which is once again mid to late diastole. So this is kind of a cyclical event of the opening and closing of valves, the squeezing of the chambers, and the relaxing of the chambers. Only the ventricles. Remember, we're only looking at what's happening with the ventricles. And I want to point out here as well, the heart spends much more time in diastole. That's really important. The heart needs to fill adequately in order to then eject adequately. And so it's going to spend 2/3 the entire phase in diastole and about 1/3 of that phase in systole, because it needs more time to fill than it does to empty. Okay. Let's look at the atrial and ventricular pressures, which are basically the bottom components here. So we're going to look at these one by one, what's happening with the pressures, and then eventually the heart sounds. We've already talked about the echocardiogram or the electrocardiogram, and so we'll talk about that towards the end. So phase one is the middle of diastole. This is where the atrial pressure is rising slowly with the filling of blood. And I want you to remember this idea that blood is also creating a change in pressure. So volume creates a change in pressure. So as that atria fills, it is now slowly increasing the pressure in that chamber, and the blood is moving into, into that ventricle. So the ventricular pressure is low, the atrial pressure is high, and so that's going to cause that opening of the AV valves. And towards the end of phase one, and we'll look at this curve here, we see the slight increase in the pressure in the atria. And that's happening as the atria attempt to squeeze that very last bit of blood out of the chamber. So the atria are not actually squeezing throughout most of the phase of phase one. Instead, the atria only start to squeeze towards the very end of the atrial contraction of phase one. And that is just to get that last bit of blood out. So we usually see this bump in the curve towards the end of phase one, which is just showing us the start of that atrial contraction. The beginning of the emptying of the atria is really a passive process as well. Phase two, which is the isovolumetric phase, is a rapid rise in the pressure in the ventricle. Here we're going to see that the pressure in the atria is going to fall. Here the AV valves are closed, the semilunar valves are closed, so there's no movement of volume during this brief isovolumetric phase. All we see is the rising of the pressure in the ventricle, which is preparing us for the ejection. And so here the pressure has to get higher than the pressure in the artery in order to open up the semilunar valves. And then in phase three, we see that the ventricular pressure falls. Remember, blood is leaving the ventricle. So as that blood leaves the ventricle and makes its way out into the artery, the pressure in the ventricle is going to likewise fall. And it's going to fall until it's now lower than the pressure in the artery. And so the semilunar valves will close, but it's too high. It's not lower than the pressure in the atria. So the AV valves are not open just yet. And so in phase three, we start to move towards the emptying of the chamber, and then we begin diastole, which is a new relaxing phase, which is phase four. So the final phase, phase four, we see the pressure in that chamber drop as we prepare the chamber to then receive the blood from the atria once again. And so we said phase four and phase one are really the diastolic phases. So remember, the heart spends much more time in phase four and phase one than it does in phase two and three.